Okay, so we can extend this idea about the measures of the angles of a polygon. We talked about the interior angles of a polygon. So now we're going to talk about the exterior angles of a polygon and what they should add up to. And this one is actually way more straightforward. There are no formulas involved. The sum of the measures of the exterior angles of a polygon is 360 degrees. This works under the assumption that there is only one exterior angle at each vertex. And so let me explain what that means in a little bit. So I'm going to use a simpler shape like a triangle. So let me go to my triangle tool here. Okay, and I'm going to pull out just any size triangle. It doesn't matter. I'll make it this big. Okay, so what this thing is claiming is that if you are going to add up all of the exterior angles, that you can extend one of the sides, right? At each of these vertices, all three of them, I'm allowed to extend one side out. So for example here, I could extend this one and create this angle right here. I'm not now allowed to extend the other one out and try to create a brand new angle. One side can be extended and that's it. So I can come down here and maybe extend this one out. Let me make that a straight line. Okay, I can extend this one out and create an angle there. And maybe on this one I extend it down and create an angle there. So every single vertex has one straight line coming out of it and I'm creating one exterior angle. What I'm claiming is that these three angles that I just created, okay, they are going to add up to 360 degrees. I don't know what they are. I don't know what the measures of the interior angles are, but I know that when I add these three angles up, I'm going to get 360 degrees. Okay, and that's true of all shapes. If I extend this to a four-sided shape or a five-sided shape, it's going to work just the same. So let's take a look at a slightly more advanced problem, and we're going to talk about what is the measure of angle 1 in this regular octagon. So if you notice, what we did is very similar to my triangle. We extended each of the 8 vertices where the angles exist. We extended each of those out with one straight line, and we created 8 different exterior angles, right? 1, 2, they're all labeled for you. 3, 4, these little spaces here, 5, 6, 7, 8. So we created 8 exterior angles. Each of those exterior angles is going to be part of that total 360. So in this case, because it's a regular octagon, each of those angles is also equal to each other, equiangular when we're talking about regular shapes. So I know that there are 360 total degrees for exterior angles. If I divide that by the fact that I have 8 total angles, 360 divided by 8 is 45 degrees. So I'm going to say each of these exterior angles has to be 45 degrees, right? So we can expand this idea to talk about the measures of regular polygons or the measures of irregular polygons and their shapes as well. Okay, so here let's wrap it up by looking at maybe some algebra that takes these interior and exterior components and puts them together. So in this case, I'm giving you this picture that has a x, y, z, and a w, and our job is to figure out the measures of each of these variables, right? So using the fact, right, if I were to look at the inside and say, like, okay, I could figure out that x plus y plus w is equal to 180, but I can't figure out what any of them are individually. So if I go to the exterior part of the shape, I can say, well, z plus z minus 13 plus z plus 10, the 3 exterior angles, should add up to 360 degrees. So if I say z plus z plus z, I get 3z, okay, and 0, right, I have nothing here. Negative 13 plus 10 is negative 3. That the sum of these 3 angles should be 360 degrees. So let's figure out what happens. 3z is equal to 363. So that means z is equal to, looks like 121 degrees, right? So this is 121 degrees. Okay. This one right here would have to be 131 degrees. And if I subtract 13, I get 108 degrees, right? So I can find the measure of those angles. The reason I found the measure of those angles is, remember, an exterior angle and the one right next to it, these two right here, are a linear pair, so they should add up to 180 degrees, right? So if I say 121, it looks like this x value has to be 59 degrees in order to complete my linear pair, right? If my one right here is 131 degrees, this one has to be 49 degrees. If this one is 108 degrees, that means that w, to complete that, would have to be 72 degrees. And I can use that concept to figure out the measure of all of the angles just by knowing that the exterior angles are going to add up to 360. Right. So one more. Again, here are my four exterior angles. 1, 2, 3, 4. I only have one at each vertex. Right. So that's good. So I know that the sum of these angles is 360 degrees. So x and 2x, well, that's 3x. 3x plus 3x is 6x. 6x plus 4x is 10x. So the sum of these four angles is 10x. That should be equal to 360. So the value of the variable here, it looks like, is going to be 36. Right? So we can do this for any number of problems using just the one key fact that the exterior angles of a polygon, assuming that we have only one exterior angle at each vertex, is always going to add up to 360 degrees.